In this video, we're going to graph functions by applying transformations to the basic functions. So this g of x here is based off of the parent function y equals x squared, the quadratic function. It looks like a parabola. We'll talk a lot more about parabolas later. Starting with a graph of the basic functions, graph the following function using the techniques of shifting, compressing, stretching, and or reflecting, and find the domain and range of the new function. So our parent graph of x squared has characteristic points, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And we're going to shift all of those up 4. So -2 is going to be 8. And -1 is going to be 5. 0 is going to be 4. 1 is going to give me 5, and 2 is going to give me 8. There's my parabola up there now. Still with the same shape as before, because these are what we call rigid transformations. It did not stretch or dilate the graph at all. Now this transformation is going to shift us 1 to the right, is what that's going to do. Remember that the square root function has characteristic points of 0, 1, 4, and so on. This is going to be square root of 0, 0, square root of 1 is 1, square root of 4 is 2. Let's go out to 9, 3. And I'm going to shift all of those x values 1 to the right to get the same y value. So now we're going to have 1, 0, 2, 1, 5, 2, and 10, 3. It's going to be really hard to see the shift 1 to the right here, but they did that with C. You can see that it moved just a little bit to the right there. Find the domain. That's going to be -infinity to infinity. Oh, I didn't answer the questions up here about domain and range. -infinity to infinity. And this graph now goes from 4 to infinity. The range here is going to stay the same of 0 to positive infinity because it was just a horizontal transformation. It did not move up or down at all. Let's look at number 3. This has a horizontal shift 3 to the left, and then it has a vertical shift 2 down. So we're going to start with looking at x cubed, and its characteristic points were 0, 0, -1, -1, -2, -8, 1, 1, and 2, 8. So I'm going to shift these characteristic points 3 left and 2 down. So to go 3 to the left from 2 will get me to -1, and then that, oh, I'm sorry, so original here, so -1 is going to be -1, this is 0, this is 1. I want to shift this 3 left and 2 down, and 3 left and 2 down, and 3 left and 2 down, like so. The domain of this, let's go ahead and shift this 3 left and 2 down. I'm still going to go right 1, up 1, left 1, down 1, right 2, up 8. So 6. And then left 2, down 8. So this is going to be -10. And this is going to look like this. This still has the same shape as x cubed, just been shifted left and down. So there we go. And so domain is still negative infinity to infinity for x, and negative infinity to infinity for y for the range. Now we have a non-rigid transformation going on here, a dilation. We're multiplying y values by 3 here. So let me take a look at the original x squared, 0, 0, negative 1, 1, negative 2, 4, 1, 1, 2, 4. First thing that I want to do is shift everything to the left 4. So x plus 4. So my new x value, x and x plus 4 squared. So left 4 is going to make this negative 6, negative 5, negative 4, negative 3, and negative 2 with the same y values, like that. Then the next thing that I want to do is 3 times this is going to give me 12, 3, 0, 3, 12. Then the next thing that I want to do is 3 times this. Let me write that down here. So x values are negative 6, negative 5, negative 4, negative 3, negative 2. Let's wrap up with my function 3 times x plus 4 squared minus 2. So 12 minus 2 is 10. 3 minus 2 is 1. 0 minus 2 is negative 2. 3 minus 2 is 1. 12 minus 2 is 10. I'm going 4 to the left and 2 down here to get my vertex. And when I go right 1, I'm going to go up 3, 2, 3. When I go left 1, I'm going to go up 3. When I go right 2, instead of going up 4, I'm going to go up 12, which is going to get me up here. And left 2 also up 12. And you'll see that that is like so. So we want you to start by actually doing the transformations by hand like this, and seeing what the new ordered pairs are. We actually want you to not have to do this by the time you get comfortable doing several of them, and just do like I did and say, well, that stretch factor of 3 is going to take what was normally the 1 here, and it's going to stretch it by 3. So I'm going to go right 1 and up 3 from that new vertex. And then instead of going right 2 and up 4, 4 times 3 is 12. So I'm going to go right 2 and up 12. I'm not actually going to calculate the ordered pairs every time. I hope that makes sense. So the domain here, let's look at the graph, as negative infinity to infinity. The range starts at negative 2 and goes off to positive infinity. All right, let's look at the next problem here. The graph of the following function. Graph it using the techniques of shifting, compressing, stretching, and or reflecting. Start with the graph of the basic function and be sure to identify at least 3 key points. Find the domain and range of the function. So we're going to go right 2, then multiply the y value by 3, and then add 1. This is going to be just follow the order of operations. So inside the parentheses first, then multiplication, then addition. So x minus 2 so we're going to add 2 to our original x values here. Would have been 2 and then 3 and then 4 plus 2 is 6 and 9 plus 2 is going to be 11. This is going to be 0, 1, 2, and 3. And then 3 times that is going to be 0, 3, 6, 9, and then plus 1, 1, 4, 7, 10. And so we have the 0.21, the 0.34, the 0.67, and the 0.1110. And when we look for those points, we see that that is going to be B. The domain of this is going to be x greater than or equal to 2, so 2 to infinity. And the range is going to start at 1 here and go to positive infinity. Let's look at this cubic function. We have a shift to the right, a reflection over the x-axis, making the y values the opposite, and then adding 3. So originally on the cubic function, we have -1, -1, 0, 0, and 1, 1. So we're going to shift 1 to the right is going to give me 0. That's going to be 0, 1 when I reflect the y value. So 0, 1, and then add 3 is going to be 0, 4 there. And then 0 plus 1 is 1. Multiply 0 times -1, I still get 0. So that's going to be 1, 0. And then that's going to be 1, 3. Move 1 to the right is going to be 2. That turns into 2, -1. And then add 3 is going to be 2, 2. So let's look at this as 1, 3 is my new centroid here, 1, 3. Now, instead of going up and to the right and down and to the left, I'm going to go up and to the left and down and to the right. So normally I'd go right 1, up 1. I'm going to go left 1, up 1 here. I'm going to go right 1, down 1. And normally I'd go right 2, up 8, but I'm going to go left 2, up 8. So from this is going to be -1, 11. It's going to be up here. And then right 2 is going to be 3. And down 8 is going to be -5. That's going to be down here. And we get this shape for the graph like this. And it should still look cubic. And the graphing tool is going to make that look excellent on my lab. So you'll know exactly what it's supposed to look like there. The domain is going to be -infinity to infinity still, because it goes all the way to the left and all the way to the right. And your range is still going to be -infinity to infinity because it goes all the way down and all the way up. All right, that's it for this video, and we'll come back next time and keep talking about 1.5. See you for the next video.